Here we have part 1, simple harmonic motion and a wave in a string. Now the first part starts off with the definition of amplitude. By reference to simple harmonic motion, state what is meant by amplitude. Okay, so the amplitude is the maximum displacement from the equilibrium. Do I need to write that down? I don't think so. The maximum displacement from the equilibrium. So if I just use an example, for instance, of a spring, and say there's a mass piece hanging from it. If it's still, and that would be its equilibrium point, and then if it is pulled down a certain amount, we would call that x0. That is your displacement. And then if it's simple harmonic motion, it will oscillate in between there and there. This would both be x0, x0. And the maximum displacement from the equilibrium, your equilibrium point, is your displacement. Going into this one over here, B2, question B. It says a liquid is contained in a U-tube, a liquid of density rho, and here you have your displacement. Equilibrium position of the liquid surface is there, and then you have a displacement x up there. The pressure on the liquid in one side of the tube is increased so that the liquid is displaced as shown in diagram 2. When the pressure is suddenly released, the liquid oscillates. The damping of the oscillation is small, so basically it means that your amplitude remains the same. Describe what is meant by damping. Well, when you have a situation with damping, the amplitude of oscillation will decrease, and that it would decrease because there is some frictional force or a force of opposing the motion. So there's some frictional force which decreases the energy. The energy of the system. Okay. All right, and that, as I said, that would be in the opposite direction. So that will cause, in a damping situation, if you've got your wave drawn, you would get something like this. So if this is your amplitude here, you would start off and go there, and then your amplitude would decrease. Now, from this formula over here, we can see that our maximum total energy, is dependent on our x0 or our amplitude, and as that decreases, obviously the energy of the system will decrease. Now we get here the displacement of the liquid from its equilibrium position is x. The acceleration a of the liquid in the tube is given by this expression. So we get a is equal to minus 2g over L x, and we are told where g is the acceleration of free fall, that's 9.81, and L is the total length, which is 32 meters, 0.32 meters, sorry. Determine the period of oscillation. Now, to do this, we need to think of our formula that A is equal to minus omega squared x. So when we compare these two, we see that omega squared is equal to 2g over L. This is your definition of simple harmonic motion, that your acceleration is always proportional to the x. As it is here, you can see that it's proportional to x, and it's towards the equilibrium, so it's always in the opposite direction to the magnitude or the direction that x is taking. So, and here we get this negative. This is a proportion value, this is a constant value. 2g over L is a constant. So we have that. So now, so we're going to get omega is equal to the square root of 2g over L. And then finally, we are actually wanting to determine the period. And we know that period over here, t is equal to 2 pi over omega. So we'll need to put that into our equation. Once we found omega, we'll need to put that into there and solve. Hopefully you'll be able to do that relatively easily. It works out that your period works out to be 0.80 seconds. Hope you'll all be okay with that. The G is 9.81 here, 9.81. This is 0.32, so it's 0.32. We put into that, we work out what omega is, and then we put that omega into there, and we get our T value. Great. Now going over the page here. Now we've got a bit of a different situation. We have got that a wave is traveling along a string. The string can be modeled as a simple line, as a single line of particles, and each particle executes simple harmonic motion. The period of oscillation is 0.80 seconds. So we've got, this would be a transverse wave, so your actual particles, so for instance this particle P is actually moving like that between these two positions, moving up and down like that. The definition of transverse wave is that your particles themselves in the medium are moving at right angles to the direction of the wave. The wave is moving in that direction. So let's go to the first question there. It says, on the graph, draw an arrow to show the direction of motion of particle P at the point marked on the string. So we're looking at this one. Now, you've got to think of the next instant in time. What is going to happen in the next instance of time? Well, if the wave is moving in this direction, so this part of the wave will be passing point P and causing P to go up. So if I just had to draw this in, we would probably get something like this. Something like this in the next instance of time. So P would actually be over there. So P must be moving in that direction upwards. So there's an arrow going upwards. Determine the magnitude of the velocity of particle P. Well, let me just draw because we're going to have to take points off here. Which formula am I going to use? Well, here I've got, this is for simple harmonic motion, I've got this formula over here. So V is equal to, now it says over here the magnitude. So we're not worried about direction, so I don't need to worry about the plus minus, which just is giving me my direction either in positive or in the negative direction. But we've got omega. Now we are told the period, are we not? We're told the period is equal to 0.80. So I can use this formula over here directly substituting into there. So I'm going to get 2 pi over T, and then we get the square root of x0. So x0 is your maximum point that you move from an equilibrium position. So that is going to be 5, and it's in centimeters there. So let's put that into meters. So it's going to be 0.05 squared. And then I'm going to subtract minus the actual, this actual x that I am at that point. So if I put that in there, I'm going to get 3. That's 3 there. So it's going to be minus 0.03 squared. And obviously this T is given to us, as we said before, is 0.8. And so I'm going to substitute that in, and you're going to get your velocity, and it should work out to be 0.31 meters per second to the negative 1. As we were given our values into two significant figures, we give two significant figures there. So it's quite straightforward if we just use our formula and we understand what each term means. Now finally on here, show that the speed of the wave is 5 meters per second. Now I think we would have, in looking at this graph over here, you would see that your wavelength your wavelength is one full wavelength is at 4. So we've got our wavelength is equal to 4 meters. Our frequency, which is equal to 1 over t, that is going to be 1 over 0.8. So our velocity of our wave, which is equal to frequency times wavelength, from that formula over there, is equal to 1 over 0.8 times by 4. And that gives it as 5 meters per second to the negative 1. And finally, for the last question, now we're going to need to come back to this graph again, but let's just read it. On the graph opposite, label the letter X. The position of particle P at time is equal to 0.4 seconds. So we're wondering what's going to happen to that P there. 0.4 seconds. Now, we've got to do it on the graph. Now, we know that our period is equal to 0.8. So 0.8 seconds is the full period. So 0.4 seconds is half the period, and therefore corresponds to half a wavelength. So to be half a wavelength difference. So let's have a look. If that is a full wavelength of 4, then half a wavelength is 2. So if I take this 2 over here further, I'm down over there. So if I correspond to this over here, I'm going to get my point. It's going to be halfway in between. It's going to be -3 here, somewhere over there. We're going to be that position there. It's going to have come down to there, that position there. -3 correspond to -3, and obviously 0.6, the same as before. So that would be the point that you would draw. That would be your P point.